Okay, so let's take a look at a couple of questions from the What the Hess problem set. I know some of you guys are like, what the Hess, right? I'm just going to show you how to solve, say, two or three of them, and then you can kind of go back and see how to solve the others. It does take some time. I don't expect you to just know it immediately, but I do expect you to kind of try and do your best and see how you do. So let's go ahead and look at question number. I'll just pick question number 2 because that seems like an easy one to work with. All right, so question number 2, we're trying to find the delta H for this, and this is the information that we're given. This right here is our target equation. That is what we want to end up with when we add up all the reactions. The problem is, more than likely, if we add up all the reactions right now, they're not going to equal this. So these are your reactions that you have to play with. We've got 3 that we have to manipulate, so that when we add them up, we get that reaction. So I'm going to tell you how to approach this problem very slowly, and this is how you're going to do it. Remember, these are the two questions that you're going to be asking yourself frequently. Are they on the right side? Is it the correct coefficient? So let's go ahead and where do we start? From the very beginning. You look at your target equation, you look at the very first substance. It is OF2 gas. Then you look at your reactions and you see where OF2 is. Where does it show up in anywhere of the 3 reactions? So here it shows up here, and it doesn't show up anywhere else. So you need to ask yourself the 2 questions. Is it on the side that you want? And in the target equation, it's on the reactant side. On this equation over here, for equation number 1, it's on the reactant side. That's perfect. That's what you want. So we checked off for question number 1. What about question number 2? Is it the correct coefficient? So this coefficient in our target equation is 2. But the coefficient here is 1. That is not what we want. So whenever we don't have the right coefficient, we multiply the entire equation by whatever number so that we can get the coefficient that we want. What that means is we're going to have to multiply this entire equation by 2. If we multiply this equation by 2, we get a new equation. It's going to be 2 OF2 gas, which is what we want, and then everything else is doubled as well, so the reaction looks like this. So here it is balanced. And our delta H has changed. Our delta H is no longer negative 276.6. Because we doubled the reaction, we have to double the delta H. So our new delta H is twice that. So it comes out to negative 553.2 kilojoules. So that's the first one. Now, because OF2 doesn't show up anywhere else, it only shows up in one equation, and now we've manipulated the equation to get what we want, we're just going to go ahead and put a star on this. We're not going to manipulate this equation anymore. So we took care of OF2. Now we have to move on to the next substance. The next substance is S, solid. So again, look at your reactions, find where S solid is. Well, it only shows up in one place, right there. So we got to go through the questions. Ask yourself the first one. Is it on the side that you want? Yes, it is. In this reaction, it's on the reactant side. So, perfect. Is it the coefficient that you want? Well, the coefficient that you want here is a 2, and this coefficient is not a 2. Therefore, we're going to have to manipulate this reaction. That means we have to double everything. So if we multiply everything by 2, we're going to get a new reaction, and we're also going to have to double the delta H by 2, and we're going to get a new delta H. So let's go ahead and rewrite that reaction. So here it is, and after doubling all the coefficients, we get 2, 2, 2. So since it doesn't show up anywhere else, it only shows up in this one equation, and we have it the way we want it, we're going to go ahead and lock in this equation. we're most likely not going to manipulate that one anymore. But we do need to calculate the new delta H. Well, since we doubled the delta H, we have to do 2 times negative 296.9, and we get negative 593.8 kilojoules. Okay, so now we gotta move on to the next substance. The next substance is SO2 gas. So look through your reactions here, and find SO2 gas. Where does it show up? As we look for it, we'll notice that it shows up in 2 places. Now this is very important, and I should have said it from the very beginning. Once you've manipulated an equation, you scratch it off, because you're not using that equation anymore. You've updated it. And this one, we changed it. We're not using that one anymore. We've updated it. So now the ones that you have to pay attention to are this one and your 2 updated ones. So where do we see SO2? We see SO2 right here. And we also see SO2 right here. Okay, now there is another kind of comment or suggestion that I make. Anytime a substance shows up in more than one reaction, I always say just put a question mark on it and come back to it if you have to. Keep solving all of the other ones, and usually if we solve everything else, it'll work out. So we're just going to go ahead and do that. You know what? SO2 shows up in 2 different places. I'm going to come back to that one last. So now let's move on to the next substance. And in this case, our next substance is SF4. So look at your reactions, find SF4. SF4 shows up right here, and SF4 doesn't show up anywhere else. So you have to ask yourself the questions. Is it on the side that you want? In your reaction, your target reaction, it's on the product side. In this equation here that you have to play with, it's not on the correct side. It is on the reactant side. Anytime it's not on the side that you want, you have to reverse the reaction. What that means is rewrite it, but your reactants are now products and your products are now reactants. So let's go ahead and flip our reactants and products. So our new reaction is going to look like this. Alright, here it is, right? So we just switched them. So now we have SF4 on the product side like we want. So now is it on the correct side? Yes. Is it the coefficient that you want? Well, in your target equation, the coefficient is 1. In this reaction, the coefficient is 1. And since it does not show up anywhere else, we're going to go ahead and lock in this reaction. Okay, so let's go ahead and cross off the previous reaction because we've changed it. But, hang on a second, what's the delta H? What happens when you reverse a reaction? Very simple. All you have to do is flip the sign. So I'm going to go ahead and write a little R here because we reversed it. But all you have to do is flip the sign. So if our delta H is negative 827.5, well then the delta H value when you flip it is going to be positive 827.5 kilojoules. And now we can go ahead and mark off that reaction. And these are the 3 reactions now. It turns out it looks like we needed to manipulate all 3 of them. So after we've manipulated them, let's go ahead and add them up together and see if we get our target equation. Now here what you can do is this. If you see substances on both sides, you can cancel them out. You can scratch them off. So let's go ahead and go through our 3 reactions. OF2, does it show up on the product side of any of these reactions? No, it doesn't. So it's not going to cancel out with anything. What about 2H2O liquid? Does that show up anywhere else on the product side of these 3 reactions? And it turns out, yes, it does. It shows up right here. If it shows up on both sides of a reaction, you can remove it. You can take it off. They cancel each other out. Move on to the next substance, 2O2. Since this is on the product side, we want to see, does it show up anywhere on the reactant side? And it turns out that it does. It shows up right here. So, since you have 2O2 on the product side, 2O2 on the reactant side, they will cancel each other out. Moving on, HF. Does HF show up on the product side? I'm sorry, the reactant side. Does it show up anywhere in these three reactions on the reactant side? Yes, it does. It shows up right here. So, there's a little tiny issue. Oh, I'm so sorry. Okay, I missed this right here. My apologies. Not a big mistake. Just forgot to put the 4 here. Okay, much better. Alright, so it shows up on both sides. Now, had this been just a 1, then you would have only canceled out 1 HF and you would have been left with 3. But that's not the case here. The coefficient is 4, so the 4 HF, they get canceled out. Moving on to the next reaction, 2S solid. Does that show up anywhere on the product side of these reactions? No, it doesn't, so that's fine. What about 2SO2? Does that show up on the reactant side for any one of these reactions? And it turns out that it does. It shows up right here. Now here, and I referred to a similar scenario not too long ago. If you look, the coefficients are not the same. Here the coefficient is a 2, and here the coefficient is a 1. They don't completely cancel out, but they partly cancel out. You will cancel out 1 SO2, which means over here you no longer have 2, you have just 1 SO2. And moving on to the next reaction, all that we have left to play with is the SF4. Does that show up on any of the reactant sides of the reactions? No, it does not. So it does look rather messy, but if we circle all the ones that did not get canceled out, we have 2 OF2, 2 S solid, 1 SO2, and 1 SF4. So if we add up all our reactants and all of our products left over after canceling anything out, our final reaction looks like this. So, our question is, does this match our target equation? And it turns out that it does. That means we've manipulated them correctly, and to find the delta H, all we have to do is add them up. So adding up these three numbers comes out to negative 319.5 kilojoules. Alright, so the main takeaway that I kind of want to tell you from this is there is a nice and slow, calm procedure to doing this, especially if you feel very weak in the strategy. And that is this. You start off with the very first substance. You look for it in your given reactions. You ask yourself these two questions. If it's not on the right side, you reverse it. If it's not the coefficient, you multiply by any number it takes to equal the coefficient that you want for that substance. And then once you've taken care of that, you move on to the next substance, and the next substance, and the next substance. And generally, usually, if you take care of all this, you don't have to go through all this messy work of canceling things out and all that stuff. Usually, 90% of the time, it comes out perfect. And all you have to do is add up your delta H's after you've done those manipulations. But it's going to take a lot of practice. And I'm realizing that this video is about to hit 15 minutes. So what I'm going to do is I'm just going to go ahead and release some more solutions along with this video. And that way you can practice a little bit more. And I'll just give you the straight answers, like what the final option, like what you had to do, how you had to manipulate them. And then, we'll just see how you do. If you have any questions, again, feel free to send me an email.